Hi, math students. This video is to help you with your upcoming checkpoint. So what you need to do is get a piece of paper and write this down along with me. Or I also took a picture of this and attached it to this video so you could print out that page and just fill it in as we go. The choice is yours, but make sure you do this and use this for your checkpoint that's going to come right after this video. These examples are just like the problems on that checkpoint. That's why I'm doing this video. Okay, so geometric sequences. Remember, you can also pause this video at any time if you need more time to write, and then just push play when you're ready to go again. Geometric sequences are sequences where we multiply or divide to get between the terms. So you're multiplying by the same thing every time, or you're dividing by the same thing every time. Okay, so just for an example, let's start with the number 2, and let's multiply by 5 every time. So 2 times 5 is 10, times 5 is 50, times 5 is 250, etc., etc. This is an example of a geometric sequence because I'm multiplying by the same thing every time. You can do the same with dividing. Let's start with 100, and let's divide by 2 every time. So 100 divided by 2 is 50, divided by 2 is 25, divided by 2 is 12.5, etc., etc. So this is also a geometric sequence because you're dividing by the same thing every time. Okay, so that's what it means to be a geometric sequence. So if they give you this table here, again, pause the video and write this down if you need to, or if you printed it out, you already have it on your page. The values follow a geometric sequence. What is the common ratio? So now they want you to tell them, what are they multiplying or dividing by every time? Okay, so year 1 was here, year 2, year 3, year 4. You can think about this as being written out as a sequence. They put it in a table, but this is the same as a sequence. So if I had it written out like this, I'm trying to figure out what are they multiplying or dividing by every time to get from one term to the next. So these numbers are tough, right? You can't just look at this and say, oh, I know the answer is 74. Like, you're going to have to actually do the math here. And so because the numbers are getting bigger each time, I know that I'm multiplying by a number bigger than 1 because I'm making the term bigger each time. So you want to do the opposite of that to figure this out. I'm going to have to take this term and divide it by this term to figure out what I'm multiplying by. So I'm going to do that here. And I'm just going to use my phone calculator because that's what I have handy. So I'm going to take this number and divide it by this number. So 5544 divided by 5280. So I get this number 1.05. So I'm going to write that down for a minute. I think what's happening is I'm multiplying by 1.05. Let's test it. If I take that 5280 and I multiply by 1.05, it worked. I got 5544. Let's test that here. Let's see if when I multiply 5544 by that 1.05 number, let's see if I get the next thing. So 5544 times 1.05. 5821.2. Yep. So it looks like what's happening here is every time I'm multiplying by 1.05. So the way I figured that out, remember, is I did the opposite. I took the second term and I divided it by the first term to figure out what was that ratio. What was I multiplying by there? Okay, so the question said, what is the common ratio? So the common ratio would be 1.05. That's what I'm multiplying by every time. Okay, next one. Which represents a geometric sequence? So remember, we just talked about up here, a geometric sequence is a sequence that's either multiplied or divided by the same thing every time. So let's look at what's happening here. So 6,000 to get to 3,000. What did they do? Well, that's divided by 2, right? Does that work here? 3,000 divided by 2, is that 1,500? Yeah, I think so. Divided by 2, 1,500 divided by 2 is 750. Yep. So far this one looks pretty good. Let's check the others. 6,000 to 3,000. Well, that could be dividing by 2, right? And then 3,000 to 0. 3,000 divided by 2 isn't 0. So what are they doing here? It looks like maybe they're subtracting 3,000 every time. 6,000 minus 3,000, and then 3,000 minus 3,000, and then 0 minus 3,000. So they're subtracting here. That's not a geometric sequence, so this guy's out. 6,000 to 5,000, and then 5,000 to 4,000, 4,000 to 3,000. To me, that looks like they're subtracting 1,000 every time. Subtracting is not a geometric sequence, so that guy's out. So which one represented a geometric sequence? It was this first one. Make sure you test all of them though. Just because we found the first one, there could be more than one that represent a geometric function or a geometric sequence. So make sure you check them all. Okay, a value in a sequence is 1/2 times the previous value, like this. So 10, 5, 2.5. So the value in the sequence is half of the previous value. So 5 is half of 10, and 2.5 was half of 5, etc. How would this be represented as a recursive equation? So recursive, these are the trickier things, I think, because they're kind of abstract to think about. So they're telling you a of 1, the first term is 10, okay? How do we get the next term? So a sub n equals the previous term. Remember how to write the previous term? A sub n minus 1. It's taking the term we're trying to get and going to the one before, a minus 1. N minus 1, a sub n minus 1. So we're going to take the previous term and do what? It said it was 1/2 times the previous term. So I'm going to multiply it times 1/2. So any term in the sequence takes the previous term and multiplies by 1/2. For me, I don't love the way that that's formatted. I might switch it to say like 1/2 times the a sub n minus 1, but either way is fine. Those are both correct. Usually we put the constant, the term, in front of the variable. Okay. Next one, what is the recursive formula for this? So we have 20, then 40, then 80, then 160. So what's going on first is what we need to figure out. To get to 20, from 20 to 40, and then 40 to 80, and 80 to 160. Looks to me like we're multiplying by 2 every time. So if I need to make one of these recursive formulas, first we need to know what the first term is, this a sub 1. The first term in our sequence was 20. You got to have a starting point. And then if you want to find any term, if you want to find the next term, you have to take that previous term and do what? We decided we were multiplying it by 2. And again, I would maybe rewrite it just personally 2 times that a sub n minus 1. Both of these are totally fine. I just prefer to write the constant first. Okay, so hopefully you wrote all these down. You guys, if you ever need more help on any of these, feel free to text, call, email, take a picture of the problem you need more help on, send it to me, and I can give you more examples on that problem. That's the best way to get help, is to send a picture of what you need help, and I can make you more videos or talk to you on the phone. So always reach out if you need help.